Okay, okay, we are recording. So last time we were seeing the rights that we have in a Unix system. So remember that we have right at the level of the user, right at the level of the group, and right at the level of others, which means other user. And there is other rights that are the set UID bit, the set group ID bit, and the sticky bit. The sticky bit only applied to directory, as we saw. The set UID bit will escalate your privilege at the level of the user, which means that you can be a normal user, and if you run an executable and the set user ID bit is set in this executable, you will have you will escalate your rights, and you will get the right of the owner of the file. And the set group ID bit is also a way to escalate your rights. And in this case, you will change your group, and you will escalate your group to the group that own the file, the executable file that you are running. So maybe to show that in more details, we are going to do a practice and then understand what is the set user ID bit and the set group ID bit. So I'm going to do a small program that will explain the difference between both. So let me edit a program and let's call it understand rights. .c, it will be a program in C. So what I'm going to do in this program is to show my real user ID and my extended user ID. So we have a function for that. Let me show you. We have a function that is called set UID. Here is the function. So what we have, we have a function that is called getUID, sorry, first. So this function will give me my real user ID. And there is another function that is called get user ID, E for extended or elevated. So this is the real one, and this will be the elevated one. Okay, so to use this function, first I need to include these two header files. So I'm going to copy them and just include them here. I'm going to do my main function. It returns an integer. It is called main, and it will return at the end a 0. Return 0. And what I want to show is my real user ID. So to get my real user ID, I need to call this function. So let me copy the prototype and paste it here and define a variable that is called UID. And we are going to call so let's put in the variable that is called UID, let's put my real user ID. And let's show on the screen what is my real user ID. So my real user, let's put UID. Let's put user ID, it's okay. My real user ID is, and we are going to show it. So it will be an integer. And we will have it in UID, no? Because this function return my real user ID. Now, if I want my extended or my elevated user ID, I have to call the other function, which is called get elevated user ID. So let me put here my elevated or extended elevated user ID, and I'm going to show my elevated user ID. So I am user Eric. My user ID is 1000, as you can see it here. Okay, so when I execute that, unless I modify some right in the file, it will show me 2 times 1000. So let me compile the program with gcc-o, I think we call it understand rights, understand right.c. Oh, there is something that is wrong here. Let me see. Printf. Oh, we forgot to include, of course, stdio.h. So I just include it, and I'm going to compile it. Okay, I could compile it, and let me execute it. So my user ID is 1000, as you can see. So let me execute it now. Understand rights, and look at what it says. My real user ID is 1000, and my elevated user ID is 1000. I didn't change my identity. Why? Let me show you how is the file. The file here don't have the S-bit set. So the set user ID. So what we are going to do, we are going to change, and we are going to make this file that will have the set user ID set. So let me change as the root user here in this window. I will be the root user. Let me go to the desktop of Eric. Let me show you the file again. So look at, we have an X in this moment here. So I'm going to change the mode, and I'm going to put for the user, I want the set user ID bit. So if I look now, the right of this file, it will have changed. And we have an S here that we didn't have previously. So now if I execute the program, let me open a new window for that. If I execute the program, I am Eric here. I am a normal user. I'm going to execute the program. Look what will happen. My elevated user ID is 100. It didn't change. Let me see. Oh, I know. Sorry for that. I have to change the owner. Let's change the owner and put the owner is root. So look, we don't have the set user ID bit in this moment. So when I will execute it, it just say 1000, 1000. Now we are going to put the set user ID. So let's verify that it is there. It is there. And look, the file belongs to the root, which means that when I'm going to execute it now, since this bit, the set user ID bit is on, I'm going to execute it as the root. So my real identity is Eric, but my elevated identity or my escalated identity is root. So let's do it. Let's execute it. So look at the difference this time. It still say, really I am Eric, but when I run this program, I have the same right at the root as the root user. So the ID of the root user is 0. Here I am the root user. Let me ask the ID. As you can see, the ID is 0. So I'm executing the program as a root when I execute it. So to make it even better to understand, let's put the name of the user as a name. So here I'm going to put a %s, %d, and here we are going to, there is a function that is called get password UID. So I'm going to use this function. So to use this function, as you can see, we need to include some header file. So we need to include those two header files. So I'm going to include them in my program if they are not already included. So systype is already there, but the second one is not there. So systype, I'm going to remove it because it is already there. But the second one was not there. So I'm going to include it. And the way that you use this function is like that. You call it, you pass it a user ID, for example, 1000, and it will return a structure where we have the username, like Eric. So let me call here, I first declare the structure that I need. So I need a structure, let's call it info user. So here, I'm going to do is to call this function and store in info user the information of the user. So info user, I call it, equal. We are going to call this function, and I'm going to pass the user ID that I just computed here. Okay? And then I need to print the name of the user. So look at this structure is described here in the documentation. And it says that you have a field that is called password name. And it will give you information, it will give you the name of the user. So what I'm going to do here, I'm going to replace the %as with info user. So it's called PW name, okay, for password name. So I show the name of the user. And here also, when I'm going to show my elevated user, I'm going to show both the name, which is a string, and the user ID. So here, I'm going to do also show info user password name. So let me compile this program. So gcc-o understand write dot c. So there is a small error in some part here, saying line 14. Yes. There is a missing comma here. Okay. Let's compile it again. Okay, I could compile it. Let me see. So the owner is the root, and I don't have the set user ID bit on, no? You can see it is not on in this moment. So when I will run here on this window, I am Eric. When I will run, my privilege is not going to be escalated. So when I show my information, my real and my elevated user ID will be the same, which is Eric. So look at my real user ID is Eric, and this is my username, and this is my user ID. And my escalated also is the same, my elevated. So now, if we make a change in this file, and we put the set user ID bit on, so now the set user ID bit is on. When I run the program, I will change my user ID. I will get extended privilege or elevated privilege. I will not be Eric anymore, I will be the root. So look, when I run it, it says my user ID, my normal user ID, my real user ID is Eric. But when I run this program, I run it as root, which means that I have all the rights. So let's try to create a directory in the root of the file system as Eric. And of course, I don't have the rights. So if I try to do that, I will have a warning saying that I don't have the right to create a directory. For example, AA in the root file system. Permission denied because I am Eric. Of course, the root can do that, no? If I go to the window of the root and I create this directory, it will have no problem to create a directory, you know? See, no message, I can remove the directory and there is no problem. So I want in this program now, for example, to create a directory. Since I know that I will be, if they put the set user ID bit on, I should be able to create it because I will have escalated privilege, elevated privilege. So to create a directory, there is a function in C that is called makedir. I think it's in section 2. Yes. So look at, we have a function that is called makedir. To use this function, I need to include these two files, these two header files. So let me see if they are already there. If they are already there, I don't put them. If they are missing, I keep them. So sysstat was not there, but systype is already there. So I'm going to remove systype. I don't need it. Okay, and I'm going to create a directory. So when you create a directory, you use a function makedir, and there is two parameters. So the path of the directory that you want to create, which is a string. So I want to create from the root file system, I want to create a directory that is called AA, for example. And then you need to specify the mode. So we are going to create a directory with this mode. Let me put here a comment. We want, it will be a directory. We want read, write, execute, read, dash, execute, read, dash, execute. We want this right for the directory. So the way that we specify the right, I think it is not here in this file specified. Let me see back. No, it's not here. So it will be in another manual which is called change mode. Yeah, so change mode will specify the possible rights. So look at, if I want to set the user ID, I need to use this constant. If I want to set the group ID, I need to use this constant. If I want to set the sticky bit, I need to use this constant. Now, there are three constants for the user. So that will be the read write, the write for the user, and the execute write for the user. There are three constants for the groups, which are here. So the first one will be the read write for the groups, the write for the groups, and the execution write for the groups. And there are other three constants for the other user. So the read write for the other user, the write for the other user, and the execute write for the other user. So we say that we want this right. So we want read write execute at the level of the user. So let me just copy that, and we are going to remove the comment. So let me put it here. So we want read write for the user. We also want the read write, the write for the user. We also want the execution write for the user, which is this one. Also, we want, at the level of the group, we want the read write. Let me copy it from here, paste it here. We also want the execution write at the level of the group. We also want, it's getting long, so let me put it here. At the level of the other user, we want the read-write. This is the read-write at the level of the other user. And we want the execution write at the level of the other user. Okay, so I think I have everything. I'm going to create a directory with that. So this function make directory return an integer. Let's go back to the function make directory. So it return an integer, and this integer is going to be 0. So if you look at the documentation, it will tell you that. Look at return value. So if this function returns 0, it's successful. Otherwise, it's return -1. So to know if it is successful, I can just define an integer, call it error. And when I call the function, I store the returning integer in error, which is a variable that I define for that. And if there is a problem, if there is no problem, error will be 0. So if error is 0, I could create a directory successfully. So let me write a message here. Directory created successfully. Otherwise, if it's -1, two possible. We did have problem to create a directory. So problem to create directory. Okay. Let's create a directory here with the right that we already said. So let me compile the program because I made a change in the program. So there is in line 27, I misspelled print. It's printf. T is missing here, a T is missing here. Okay, let's compile again. Okay, I could compile, no problem. So in this moment, we don't have changed the write. If I look at the write at the level of the file, I don't have the bit set user ID set, which means that when Eric is going to execute this program, this write will not be changed. It will be Eric up to the end, which means that it will not have extended write. So it should not be able to create a directory. So let's execute the program, and the program should say, I did have problem to create a directory. So look at, it does say, really, I am Eric. And when I execute the program, I am Eric. So I don't have elevated privilege. So look at what it shows, problem to create a directory. And if we look at the root file system, we don't have the directory AA. Okay, it is not there. This is a root file system. Maybe I can do that. We see it a little better. We don't have the directory AA. Okay, so let me now modify the write on this file. So we've changed mode. I'm going to put the set user ID bit on. So now the set user ID bit is on, which means that if the user Eric or any user execute this program, while he executes this program, he will get elevated privilege. It will be the user root. So now I should be able to create, Eric should be able to create the directory AA. So let's do it. And look at what happened. It says, really, I am Eric. And my user ID is 1000. But I got elevated privilege. So when I run this program, I am the root. And as the root, my user ID is 0. And look at, directory created successfully. I was able to create this directory. Now, if I look at here, look at the directory AA have been created, as you can see. I was able to create the directory AA. Of course, if I try to remove it like that, it will not work because I'm not the root. Okay, the root can remove it without problem, no? But I cannot. Remove dir, sorry. Yeah, here I didn't use remove dir, which was not a good idea. I cannot. And here the root can remove it, as you can see. So I got elevated privilege as at the level of the user. Now, you can also get, by the way, let's see the rights. You remember that we say we want 7, 5, 5. You see it here? On the D at the beginning, say it's a directory. When it starts with a D, it's a directory. When it starts with a dash, it's a ordinary 5. Okay, now let's see what is the group ID and how can I escalate my privilege at the level of the group. So the user Eric, the default group of the user Eric is Eric, and the group ID is 1000. Now, I want, for example, the root belong to a group that is called root. You see, the root belong to only one group, which is called root, and the group ID of this group is 0. I would like to see the effect of escalating my privilege at the level of the group. So let's complete this program. There are other functions. For example, there's a function that is called get group ID and get extended group ID. Get group ID. Yeah. Oh, I was not seeing get group ID. Thank you. Okay, so there is a function that is called get group ID and get elevated group ID. So to use this function, I need to include these two files. They are already here. I need to include UNISTD, unique standard, I think so, it is there. And I need to include sys type, it is already included. So I don't have to worry, I can just use this function that will give me my group ID. So I want to show my group ID. Let me define a variable here. Let's call it group ID. And I'm going to show my information of group now. So let me call and get my real group ID. So in the variable that I call group ID, I'm going to get my real group ID. And I'm going to show it. So my real group ID is, and we are going to represent just an integer at the beginning. So it is in group ID. And we are going to compute also our extended or elevated group ID. So to that, I will call get elevated group ID. And my elevated or my extended group ID is, we are going to show it as an integer. Okay. So I did change in the program. I need to recompile it. Here, I just recompile it. Let's see our rights. So it's belong to the group roots. So, and as you can see, we don't have the set user ID bit set, and we don't have the set group ID set. So when I run it as Eric, that belong to the group Eric, there will be no change in this moment. So let's run it, and I will not be able to create a directory, of course, no? So look at the level of the user, this is my real user ID and my elevated user ID. I am Eric, and my user ID is 1000. At the level of the group, I didn't have change. my group ID is 1000, and my elevated group ID is also 1000, it's not 0. I tried to create a directory, and I was not able to create a directory. So we want to show the group name also. If we want to show the group name, we have a function that is called get group GP, I think so, or GR. Get GR GID. GR for group. Get group ID. So look at, we are going to use this function. To use this function will allow us to see the group not as an integer, but as a name. So let me go back here. If I want to use this method, this function, I need to include this file. The other file that I need to include is already included. So I'm going to go at the beginning and include one more header file. Okay, so here we are going to define a structure, as you can see, which is called group. And here we are going to put info group. Info group. We are going to call it info group. So what we are going to do, let me copy, for example, this line here. In info group, we are going to call get GR GID. And here we are going to pass the GID. And my real group is, so we are going to show a string and between parentheses the integer. So the string will be, so this structure have the name of the group and they describe it here. So there is a member that is called GR name. So here I'm going to just put info group, and to access the member of the structure, it is called gr_name. Okay, so what is missing? Let me here do that. And here, my elevated group ID is, I'm going to show my elevated group ID as a string and as an integer. And as a string, it will be inside this. So let me just copy it here. That
on the printf statement, I think there's a typo on the info group GR.
Yeah, you're right. Info group is a G here, no? And a G here. It's okay now?
Yes.
Okay. Let's compile it. Okay. No error, no warning. Okay, in this moment, I have not changed anything. So when I run the program as Eric, it should show that I exactly the same execution here, but it will show me that I belong to a group that is called Eric. So it will show me a little more information. So at the level of the group, it shows me that the group that I belong to is Eric. Look what I can do, for example. I belong to other group. For example, I belong to the group CD-ROM. So I can change my default group and say, because my default group in this moment is, my primary group is Eric. If you look now, look at, I am user Eric, and my primary group is CD-ROM, is not Eric anymore. I belong to all this group, no? As you can see, there is a list of groups where I belong. So if I run the program again, now my group is going to be CD-ROM. So look at, my user ID is Eric. I didn't change my user ID because there is no S bit here. There is no set user ID bit. The set user ID bit have not been set. And as you can see, I belong to this group. and this group is the group 24. And I didn't change my group. Now, let's change, for example, the set group ID of this file. So I'm going to do group plus S. If you verify, I did change my set group ID, which means that now when Eric is going to execute this program, it will change its group. It will not be CD-ROM anymore. It will be this group. So since the file belongs to the group root, I will have the right of the group root. So let me execute it. And as you can see, look here, my group is group 24, which is called CD-ROM. But when I execute the program, I am in the group 0, which is a group that is called root. Okay, so I did change my group. If you put also, for example, let's put a set user ID bit in 1 for this file. So now I have both, as you can see. We have the set user ID bit that is on, and the set group ID bit that is on here. So when I'm going to execute, I will change my user ID and my group ID. My user ID will go from Eric to root, and my group ID will go from CD-ROM to root. So let's see. Look at my user ID. It went from Eric to root, and my group ID went from CD-ROM to root. So to understand it even better, let me see what group we have here. We might have other groups. So there is a file that is called etc group, where we have all the groups that are defined. For example, there is a group that is called Sally. So let me change the group of this file. So change group Sally understand write. Now let's see understand write. So understand write, let me change the owner. Let me change the mode, sorry. So the user on the group will have the S bit on. So I will have the set user ID and the set group ID on. So both are on, which means that when Eric is going to execute now this file, it will become the user root, and it will belong to the group Sally. So I will go from CD-ROM to Sally. Okay, so let me remove the directory because we could create a directory with a problem last time. We've removed directory, and let me execute the file again. So look, I went from, at the level of the user, I went from Eric to root, and I went from my default group, which is CD-ROM, to the group of Sally. So you understand what those 2 bits allow you to do? It's allow you to change your user ID and change your group ID. So it has to be an executable file and a binary file. It cannot be a script. And if you have the set user ID bit on, you will change your user ID with the user ID that is specified here. And if you have the set group ID bit on, you will change your group. Of course, Sally is not a privileged user, so maybe changing my group to Sally is not very important, but changing my user to root is very important, because when I'm root, I don't have any limitation in the system. I can do whatever I want, okay? Is it okay with this practice? You understand what I mean now with these 2 rights, these 2 additional rights that we can have? Okay, so there are very dangerous rights. So people that hacking your system, they will put files with this right on. So they can come back, they can let's say, backdoor, they can come back in your system, because as I was telling you, in the past, a hacker will try to damage your system So today they are a little more subtle. They want to be in your system and spy you for years, spy your activity. So they don't want you to detect that they are there, but they want to spy your activity. So if you generate technology, they want to steal your technology. If you store bank information like credit card information, they want to steal the information of the credit card and use the credit card illegally. So most of the time, they don't want to damage the system, but stay there. So they need to have backdoors to come back on the system at any time. So they will create, of course, files that have special privilege for them to come back when they need to come back. Okay, so we are going to see how we find those files that have, for example, the set user ID on or the set group ID on. So there is a command that is called find. This command is very powerful. I'm going to show you a little how to use the command find. So here I am root, and I remember that one of the tasks that I asked you at the beginning is to find all the configuration file that was in the etc directory. So some of you, for example, told me we can do that. Star.conf. And it will show you all the configuration files that are in the etc directory. So it will show you that, that's true, but it will show you even more than what we want. So to show you that it will show you more, those are the configuration file, no? So look at, if they start with a dash, they are ordinary files. So all of them are ordinary files, as you can see, and we can say, yeah, it did work. The problem is that I can, for example, create a directory that is called, let's create a directory here, that is called, for example, jsu.conf. This directory now will appear in the listing. Look at it, it is there. It did appear. I don't want it in the listing. So let me create in jsu.conf, which is a directory, let me create some file. So let's create a file that is called, for example, file01.txt and file02.txt. And let me give you again this command. Look at this command, since there is a directory that ends with .conf, show me the content of the directory. You remember I create two files inside the directory. Let me create another directory that ends with conf. So let's call it, for example, Jacksonville conf. And let's create inside file. For example, we are going to create alabama.txt, oxford.txt, and Anniston. And I do the command again. Of course, the two directories and the content of this directory are going to appear in the listing. So look, it says, yeah, you have this bunch of files that are configuration file, but you have also a directory that ends with .conf, and the content of the directory is we have 3 files inside, and you have another directory that is called jsu.conf and have 2 files inside. So my question was only, show me the configuration file. So this command, if you have gave me this command, I will put a note. It gives you more than that. As you can see, it did give us more. So we can, for example, use another command, the find command. The find command is very powerful. So let me explain you the find command. It will allow us to find in the file system for some files. So look at what I'm going to say. The find command, you need to tell where to start in the file system. So I'm going to tell the find command to find searching in the etc directory. And I'm going to say find file, which name is like that. Something.conf. So it will give me all the file, but also all the directory. But it will not show me the content of the directory. So look at what is showing me. Oh, it's showing something that I forgot to say. So the jsu.edu should be here in some place. Let's see if we see it. Okay, it is there, the jsu.conf. And the other one, that is jacksonville.conf, should be also here. Let's see if we see it. I cannot see it here, but in some place it will be there. If you see it, let me know. Go up.
Yeah, I think it was down there. Like, oh, there it is, towards the bottom.
Okay, here it is. So we have here the jacksonville.conf. So it does appear. So there is another thing that we can see is that all of them are in the etc folder, but it will go recursively. So for example, this is a configuration file, but this configuration file is, we have the etc directory, and inside the etc directory, we have another directory that is called ghostscript. Inside ghostscript, for example, we have seedfmap.d, and finally, we have a configuration file. So it's go recursively. If you look here, we have /etc security, which is a subdirectory, and access.conf. So there is a way to tell how deep recursively it has to go. So I'm going to say, look at, when you want to put another condition, there are many conditions that you can specify. So there is a possibility to add this condition, max def 1, which means that recursively you go only at one level, which means that it will stay in the etc directory. So look, if I do it, the list is much more smaller. We can see it here. All of them, there are not much. So it starts here with etc add user up to this one. But we will see in the list, this is not a file. This is a directory that I created. And the Jacksonville is also here. It's a directory that I created. So there's another way to even specify more condition. So I can say the type should be a file. So look, when you go recursively, go up to one level. When you show me only files, ordinary files. The name of this file have to be something.conf. This will perfectly work. So if you look in this list, we don't have jsu.conf and we don't have jacksonville.conf because they were directory. Now, look, if I say, show me the directory, not the file, it will show me jsu.conf, which is a directory that ends with conf, and jacksonville.conf. So with the type option, you can specify if you want files or directory, ordinary file or directory. Okay, so that was a good answer for this exercise that you have to do a few days ago. That will be exactly what I want as an answer. You show the files, the ordinary files that end with .conf. They are in the etc directory, and you don't go recursively. Or the recursion stop at level 1, which means that you just stay in the etc directory. Okay, So this command is very powerful, and it allows us to do a lot of things. For example, let me create some txt file in the etc directory. So let me do touch etc. Let's create, for example, let's create France.txt. Let's create Italy.txt. Let's create Ukraine. You know what is going on in Ukraine, no? Unfortunately. .txt. So I create 3 files. So if I want to show the txt file, I can do that. Show me the txt file with def1 that are in the etc directory. So look at it, show me the 3 that I just created. Now, if I want to show the txt file on the conf file, we can do it. So look at what we can do. We can say we want to go with a max def of 1. They have to be 5. And here we can say the name have to be something.text, or the name have to be something.conf. So you see the or here. So the name have to be something.x, something.x, or the name have to be something.conf. So it will show me these 3 files plus all the configuration file. So look at the list that I have here. So as you can see, we have the configuration file. Here we have Italy. Here we have Ukraine. And here we have France. So they are also in the list of files that I just asked, no? So this command is very, very powerful. To show you a little more its power, let me create a directory here. Directory. That means go inside. Now I want to create a file that is called f0005.bin. I want to put 5 bytes in this file, and those bytes will be 0. So I want to put 0, 0, 0, 0, 0, 5 times. 5 times 0. When I say 0, I mean the byte have to be 0. So when I look at the content of the file with an hexadecimal editor, I should see 00, 00, 00, 00, 00, 00, 00. How can I create a file of 5 bytes and I want the 5 byte to be 00? How can I do that? Do you have any idea? So we can use the echo command. Let's say that I want to put A, B, C, D, E inside, which is in hexadecimal 41, 42, 43, 44, 45. What can I do? A, B, C, D, E. And I'm going to say, do not put the enter. So look, let's see the file that I created. I create this file. It has 5 bytes. If I look its content with XD, let's put by group of 1 to see them well. By group of 1, we have A, which is 41 in hexadecimal. We have B, we have C, D, E. So let me remove this file, and I tell you again, I want a file of 5 bytes. But when I run this command, I want to see 00 here, 00 here, 00, 00, 00, 00. How can I do that? So I can still use the echo command, no? You can say the echo command, okay, you are going to specify the byte with its hexadecimal value. So the first byte is 0, the second is 0, the third is 0, the fourth and the fifth. So now if I look, sorry, I need to put enable interpretation of them. Okay, now if you look, we have 0, 0, 0, 0. If I want to put 0, 0, 1, 0, 2, 0, 3, 0, 4, what can I do? Just do that, no? 1, 2, 3, 4. Did I put enable interpretation? Yeah, I did put enable interpretation. So I think this is missing, saying that we are in hexadecimal. Let me see. Okay, here it is. We are specifying the value in octal. So we have to start with a 0. If I want to put, for example, let's say here, 2, 0, what can I do? 2, 0, 2, 1, 2, 2. Let's put 2, 0, 2, 1, 2, 2, to A to B. 2, 0, 2, 1, 2, 2, to A to B. What can we do? So you want to specify the byte in octal. So 2, 0 will be an hexadecimal, no? So if I want 2, 0 will be an hexadecimal. If I want it in octal, what will be the octal of 2, 0? Let me open here an editor. So 2, 0 is 1, is there a way for me to make that bigger? So 2, 0 will be 0, 0, 1, 0, 0, 0, 0, 0, but that's hexadecimal. If I put it in binary, it will be, if I put it in octal, it will be what? That is 2, 0 in hexadecimal, no? If I put it in octal I have to do group of 3. So I will do what? 0, 0, 1, 0, 0, 0, 0, 0. This is the octal. And in octal it will be what? 0, 4, 0. Isn't it? So if I want 2, 0 at the beginning, let's do just 1 byte. I need to put 0, 4, 0. Let's see, it should have only 1 byte, and you have 2, 0. So I want 2, 0 to 1 to 2. So I have to put, the next one will be what? For 1, for 2. So we will have 3 bytes, 2, 0 to 1 to 2. Let's verify it. 2, 0 to 1 to 2. Now I want 2A. So let's go back here. What is 2A? 0, 0, 1, 0, 1, 0, 1, 0. But this 2A is hexadecimal, no? If I have to specify it in octal, it will be what? 0, 0, 1, 0, 1, 0, 1, 0, isn't it? And this will be what? So the first group of 3 bits is a 0, then we have a 5, then we have a 2. So in octal, it will be that. Okay. So since I'm going to specify the value in octal, I have to specify 5, 2 for the next one. So look, 0, 5, 2, 0, 5, 3. So we'll have 2, 0, to 1, to 2, to A to B. Let's verify. Okay, 2, 0, to 1, to 2, to A to B. We have 5 bytes and they have the value that I want. Okay, what I want to do is to generate, let's say 201.5. So the file 0000.bin will have 0 bytes. The 5001.bin will have 1 byte. The 5050 will have 50 bytes. So we have file of different size. So what can I do, for example, is what I was doing. I can do echo, enable interpretation, don't put the new line, f0000.bin. Then I want to do 2 bytes. Oh no, in the first one I want 0 byte. So I have to do that. 0 byte. In this one I want 1 byte. In this one I want 2 bytes, and I want the 2 byte to be 0. In this one I want 3 bytes. So if you look, the file, this one have 0 bytes. This one have 1 byte. This one have 2 bytes. This one have 3 bytes. And inside, if I look inside, for example, of the file 3, we will have 3 bytes, and all of them are in 0. So I want to do that up to file 0200, which is 200. So of course, I'm not going to do that by hand. So let me remove all these files that are here, and I'm going to create a script. So let's call it generate file. Generate files. Let's do it in bash. My hash bang is bin bash, is it? Or it's user bin bash? Let's see. I don't remember, so I'm going to ask, where is bash? User bin bash. Okay, so it's user bin bash. User bin bash. Okay, so we are going to do a for I in. We want to go from 0 to 200. So sequence of 0 to 200, 0 inclusive, 200 inclusive. Do. Done. We want to create files. So before we do that, let me show you another way to create a file, for example, of 100 bytes, and we want 100 zero inside. So one way will be doing what I was doing, which will take a long time, no? Enable interpretation, don't put the new line, and I write 100 times 0, D0, blah, 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 up to 100, and I put it in f0100.bin, for example. That will take me a long time because I have to be sure I write 100 0. So another way, there is a command that is called dd. Look at the syntax of dd. You say, who is the input file? So we have a file that is called dev0. This file, look at it, starts with a C. It doesn't start with a dash or a D. It's not a directory. It's not an ordinary file. It's a special character file. And this will generate 0, the number of 0 that you want. So you just have to stop it when you don't want more 0. So I'm going to use this file to generate 0. And I want to generate exactly 100. So let me show you the syntax of the command dd. So you say, who is the input file? The input file will be dev0. And you say, who is the output file? The output file, for example, will be f0100.bin. So you say how many times you want to write in the file. I want to write 100 times. And you say, what is the block size? The block size, every time that I will write 1C, 1 character. So 1 character 100 times will be 100 bytes. So it generates the file. Look at the file is here. Look at the size of the file, 100. And inside we will only have 0. So we can verify it. I can use the xxd command. Let me put by group of 1 of this file. So if you look, it is filled with 0, and we have exactly 100 bytes. So another possibility, if you want a random content, instead of using dev 0, there is a dev mu random. So it will create a file of 100 bytes, but the bytes are going to be random. So look, you see we have 100 bytes, but inside we have random values. Okay, so I'm going to use the dd command to create my files with value inside that are 0. So what should I do here? I'm going to do dd input file equal /dev 0 output file, the name that I want. So I want f something here dot bin. So the number of times that I'm going to do a write is in the variable I, and the block size will be 1 character, 1 byte. Okay, so I just need to figure out how to replace this xxxx with, for example, when I is 0, I want to replace with 0, 0, 0, 0. When I is 1, I want to replace with 0, 0, 0, 1. When I is 200, I want to replace with 0, 2, 0, 0. So how we do that? So there is a print function, printf function, that, for example, is a solution for what I want to do. It's exactly as the printf function of C++. For example, look at what I can do. I can say, show me as a decimal the value 90. And go to the next slide. It shows me 90. So I can say, show me as an hexadecimal 90. So 90 as an hexadecimal is 5A. Or I can say, for example, show me over 4 characters and do left padding in 0, 90. So over 4 characters, if we do left padding, it will be 0090. Look at it, 0090. If I don't specify the 0 here, it will be padded with spaces. So look at, we have space, space, 90. So you can say, do the left padding with 0 or do the left padding with spaces. So this printf function works for me. So look at what I'm going to do here. I'm going to say, you execute the printf function, and what I want here is f, then over 4 decimal, I want an integer in decimal, and I want to do left padding with 0. This is do left padding with 0. And I want to replace the %04d with the value of I. Okay, I think it is okay. I think there is no problem here. I think our program is okay. So let's see. Let's remove this file. Let's change our write so we can execute the file that we just created. Let's see if it's works. So in this moment, we just have the script that I created, which is generate file.bash. Let's execute it to see. Let's see the result. So look, file, we say from 0 to 200. Now, let's see if they are the correct size. Long. So the 50 have size 0, the 51 have size 1, the 510 have size 10. Let's see. For example, the 110 I size 110. Okay, we did it right. So now we have files of different size. Okay, why I want to do that? Because I want to show you other benefit of the find command. Let's say that I want all the file of size 30. So we have only one file of size 30, no? Which is this one. So it should show me this one. No, this is 130, sorry. 30 is this one. So it should show me this one. So how can we do that with the find command? Find where you are, all the file which size is 30 character, 30 bytes. Look at the answer. Say there is only one file with 30 bytes. Let me create a copy of this file. F0030. Let me call it copy.bin. Let's create a third copy that we call, for example, good.bin. Now I'm going to ask the same question. Show me all the file with size 30 character, 30 bytes. We have three files. We have copy bin, we have good bin, and we have F0030.bin. So look at them. Show me the three files, as you can see. So if I want the files that have size 30 bytes, or 50 bytes, or 100 bytes, what can I do? I can say the size is 30 bytes, or the size is 50 character, or 50 bytes, or the size is 100 character, or 100 bytes. You see the command? Let me execute the command. So it show me the 5, the 100 here, which is this one, the good, the 30 and the copy come here, and the 50, which is this one. You see the power of that? Now let's say that I want all the files that have size between 28 and 32, both inclusive. Before we do that, I want all the files that are a size smaller than or equal to 3. So we can do that. If we want a size smaller or equal to 3, look at, we can put -4 byte, -4 character, which means that it have to be less than 4. Less than 4 means it can be 0 byte, 1 byte, 2 byte, or 3 bytes. So this will show us 4 files, the 0000, the 0001, up to the 0003. So look at them. The 0 is here, the 1 is here, the 2 is here, and the 3 is here. Because I say the size have to be less than 4 character. Now, if I say the size have to be greater than 197 character or 197 bytes, how many files I will see? So I will see the 198, the 199, and the 200, because we generate up to 200. So I should see 3 files. Look at. So the 198 is here. The size is bigger than 198. The 199 is here, and the 200. Now, if you want to say the size have to be between 28 and 32, inclusive. I want to include 28, and I want to include, so what I want is 28. I want the size, and we say 42, for example. So I want to include the 28, the 29, the 30, the 31. Let's put 32, too much. The 30, the 31, and the 32. How can I do that? I want a size between 28 byte inclusive up to 32 byte inclusive. How can I do that? So I can say find starting in the current directory. So file, which size is what? Is greater than, we say 28. So greater than 27. When I say greater than 27, it will put 28, 29, blah, 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 blah. And the size less than 33. 33 character or 33 byte. You understand? So here it will show the file that have size 28, 29, 30, 31, and 32. Okay? So 28, there is only one file, which is f0028.bin. 29, there is only one file. 30, we have 3 files, no? We have good, I don't remember the name that we put. We put good, copy, and we have f0030. 31, we just have one, and 32, we just have one. So 28, 29, 33, 31, 1, 32, 1. So we will see 7 files. So let's execute that. So let's see, the 28 is there, which have 28 bytes. The 29 is there, which have 29 bytes. The 30 is there. Remember that good also have 30, and copy also have 30. The 31 is there, and the 32 is there. So you see, you can even specify the size, a specific size or a range of size with the command find. But the command find do much, much more. For example, there is an option that is perm. So let's understand the option perms. So let me remove all this file that we created here, all the f something. Let me remove the good. We create a good, we create a copy. What else we create? That's it. Okay, let me remove the generate. I don't need it anymore. So to understand how to manage the write, let me create some file. Touch F. I'm going to create file from, for example, from 120 to 150.bin. So I will have f120.bin, f121.bin up to f150.bin. Let's see the file. So you see, from f120.bin to f150.bin, because I say here I want value between 120 and 150. So all those files have this right. Let's say that I want the 150, maybe there are too many. Let me remove some. We are going to remove F144 to 150.bin. Let's see. Okay, the number is much smaller. So from 120 to 143. Good. Let's say that I want here just have to do, I want to have r dash 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 dash. What can I do? I can do 400 for this file. Now let's say that for this file, the next one, I want dash w dash 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 dash. What can I do? was the 121. So let me do the 120 and the 121 like that. So we have R, W. Here I just want the X for the 122. So for the 122, I just want the X. Now for the 123, I just want the R here in the group. What can I do? I can put here 0, 4, 0, no? Then for the 124, I want the W only. For the 125, I want to execute only. Let's verify. Okay, we go well. Now I want to do the same thing at the level of the group, starting in the 126. For the 126, I want 004. For the 127, I want 002. For the 128, I want 001. Okay. So now, let's say here we want read-write only for the 129. So for the 129, we want 600. Okay. Let's say for this one, the 130, we want read execute. So for the 130, I want read execute. We have read execute. Let's say, for example, we want here read write only for the 131. For the 131, we want read write, which is 6. For the 132, we want read execute also. Let's verify. Read write, read execute. Let's do the same thing for the 133. 133. We want read write. 34. We want read execute. Okay. I think with that we can already do a good exercise. If I want all the files that have exactly this right. So here there is only one file, which is F123, it should appear. I can do find from the current directory, start looking. So there is an option that is perm. So perm is permission. And I want the permission to be exactly this one. So what I can write here is 040. The permission have to be in octal 040. So it will show me only this file. Let's see. You see? Now, I can also say, for example, the permission will be for the user, nothing. For the group, I want read. For the other, nothing. So I can put an octal number, or I can put some things like that. Okay, I want, let me, for example, put a read write also in this file, in the 155. So change mode. Read write will be 600 for the 155. So, sorry. I want all the files that have this right. So it show me the 129 and the 135. The right have to be read write dash 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 dash. So I can say find from this directory all the files that have the following. What is the word for English? The following what?
Rods.
Huh?
Like rods to a file?
Yeah, this is a right, but what there is a word that is this perm is permission, this permission. All the files that have this permission. And the permission that I want is 600. So it did show me this one has 600. It showed me the 129. And it showed me the 135. Now, what about if I want to say, show me all the files that have a R here? I don't mind the other bit. I want an R here. So it showed me this one. It should show me this one also. It should show me this one also, and all those one. So I want an R for the user. So if you want an R for the user, it's with this option. So R for the user will be 400. So when you say 400, what is 400? 100, 000, 000. So at least the R bit of the user should be in 1. This is what it means. When you put slash, if you put without slash, it's exactly. When you put with slash, it's at least one of these bits that I'm telling here should be in 1. So since there is only one bit that is in 1, it's exactly the R bit have to be in 1, the R bit of the user. So look, the list is a little longer. Let's check. Maybe we eliminate from the 140 to the 140 so we can see all of them. So remove from the 140 to the 143. .bin, we have less file to check. Look at that. Okay, now, sorry, I didn't do the command. So let me do it from scratch. I show all the file, and I want the file that have the R bit of the user in 1. So look, it tells me the 129. The 120 should be there in the list. It is there. What is the next one that should be there? The 130. It is there in the list. What is the next that have the R bit in 1? The 129 also. It is there. What else? From 135 to 139. So 135 is there. 36, 37, 38, 39. So all of them have the R bit in 1. What about if I want to say, I want this bit in 1, the X bit in 1 at the level of the user, or the X bit here in 1 at the level of the group? At the level of the user or at the level of the group? What should I put here? At least one of the bits. Both can be in 1 also. So I can put 0. So we say X at the level of the group will be 1. Or we say this one. So X at the level of the user. So I'm going to put 1. Or X at the level of the group. So I'm going to put 1, 0. Let's see what it shows. So here we have X. So the 122 should be in the list. It is there. Whereas we have X here. Here we have X. So the 130 should be there. It is there. And we don't have X at the level of the user. Now, at the level of the group, we have X here. So the 125 should be there. Whereas we have X here. So the 132 should be there. You see? If we want X at the level of the user, or W at the level of the group, what can we do? This, isn't it? This will say 1 Well, we have X at the level of the user or W at the level of the group. So let me do it. Let me first do that. Here it is. So X at the level of the user will select the 122. It is there. X at the level of the user will also select the 130. It is there. We don't have more X at the level of the user. Or we say we want also W at the level of the group. So W at the level of the group should show the 124. It is there. And W at the level of the group, who have W, this one. The 131 should be there. It is there. Now, how do we say we want both bits to be there? If you want both bits to be there, you have the minus option. The minus option means both bits to be there. For example, here, let's see if there is at least one. We want the X bit of the user and the W bit of the group. There is no file like that, no? So maybe we can create this one. Let's do the 136 with this particularity. So for example, change mode, we are going to put 120 for F136. And we are going to put 17. The 37. So let's see the listing again. So look, we say we want the X at the level of the user and the W at the level of the group. So this file have it. We want both. And this file have it. They are the only file that have the X at the level of the user and the W at the level of the group. You see the X at the level of the user and W at the level of the group. So let me say I want to find those files. So I want both. It's not a slash, it's a minus. So look, it's tell me one F136 and F137, which are the correct one. So you can say exactly this right, at least this right, which is, I want all of these bits to be in one, or, so I should say exactly this right, or for example, at least one of these bits, or all these bits on, at least one of these bits on, or all these bits on. So look, now I'm asking you, give me a list of files that have the set user ID bit on. How can I get a list of files that have the set user ID bit on in the whole system? Because I want to check that there have not been some change. I suspect that something happened in my system. I want to see a list of files that have the set user ID bit on. What can I write? Find from the root file system, which means starting the root file system, go all over the file system. File where the permission is what? What should I write here? So how can we put the set user ID on? You remember that with the extended part, we have 4 octal. This octal is for the order. This octal is for the group. This octal is for the user. And this octal is for the extended write. So I should say that in the extended write, if I want the set user ID on, it should have what here? A 4. 4000 mean what? Find all the file that have the set user ID on. Look, this is a list of files that have the set user ID on. So look, you remember this program, I did it. Let's check that this program has the set user ID on. So let me do a ls, show me all the write of this program that we did. It does have the set user ID on. You also have the other one, but I was saying at least the set user ID on. Look at this file, for example, the password, user bin password. Let's check that the user bin password have this bit on. Look at it is on. It's dangerous. It's normal. It's a normal behavior in this case. But for example, if you do that in your system and you see that user Eric have that, you should investigate user Eric. In his home directory, it should not have any file with this bit on. Could not have it. This is not, a user cannot have that, a normal user. So of course, this one is the command that I use to change my password. And when I change my password, I get temporary root rights to be able to change the system because it's a system file that I need to change. For example, the sudo command also have this bit on. We can verify it. So here it is. It is on, as you can see. Now, if I want a list of files with the set group ID on, what can I do? I just say at least the set group ID have to be on. So it will be 2000. Look, with 2 here, 2 is 010. So the 0, the first 0, let me write that in octal. 2 is 010. Then we have 000, 000, 000, 000. These 3 0 are for the others. These 3 0 are for the group. These 3 0 are for the user. And this 0 is for the set user ID. This one is for the set group ID. And this 0 is the sticky bit. Okay, so 2000 say that I want at least the group ID bit in 1. So let's see. So this is the list. So you check in the list and you see that user Eric have it on. You have to investigate user Eric. In the home directory of user Eric, we have a file that have this bit on. So now, for example, the cron tab have it on. The file cron tab is totally normal. Let's verify that it have it on. As you can see, it have the group ID on. This is totally normal. The write all command to write a message to all the user, it is on. This is also a normal behavior. There are some files that must have them. As you can see, we have this bit on. Okay, so you can, with powerful command, go and investigate your file system. Okay, I just realized it's time. Let's stop here for today, and we will continue with more writes when we come back from vacation, from the break.